All right, in chapter 3, we get into a comparison of two variables here, and we're going to look at situations where what we'll have is an individual, and each individual will have two variables about them, and we'll compare those. So where we start out is we talk about scatter plots again, and you've seen these before. Scatter plots simply is when I go and graph on my coordinate plane these different individuals. So each point here represents an individual. Okay, and then there's one variable that we know something about them. And then there's a second variable, and that's how we decide where we're going to put these points. Okay, now obviously these variables have to be quantitative. Okay, we can't use categorical data when we're putting together a scatter plot. Okay. Now, we'll have an explanatory and response situation, and we'll get into that more in the chapter, but what we're looking at is we think that one of my variables explains why I get a certain result. Okay. We don't want to call it cause and effect quite yet, because sometimes it will be a cause and effect, other times it won't. And when we graph this, we usually will put the explanatory variable on the x-axis, and then my response will go on the y-axis. Okay. Now, sometimes there won't be, like I said, the explanatory response relationship, and so we have to be careful of that. For instance, like a situation, if I take all the students in the class and I look at the height of their mother and the height of their father. Okay. One doesn't cause the other, so we got to be careful with that. All right, and one of the other things that we'll do is we'll get into our describing, just like we did with our histograms, stem plots, dot plots. We always had to talk about describing my graph, what I see, my distribution. Okay, and we talked about sucks as a way to remember that. Well, what we use in describing scatter plots is going to be suds. So it's just going to be one little change. So we still look at shape. Okay. And what we look for is a situation, do I have a relationship that's linear or is it not linear? It's as easy as that. Does it look linear or does it not? And when I talk about does it look linear, does it look like I could draw a line in there that would fit that data fairly well? Or does it look more like a curve or something going on? Okay. Unusual still looks for outliers. Okay. You may have situations where you get an outlier in that spot where it still kind of falls in our pattern, or you might get an outlier over here that falls not in the pattern, and we'll talk about the difference between those eventually as well. Okay. Direction. Okay. Direction, we talk about association. Association is going to be positive or negative. Okay, and so positive is just like slope. As x increases, my y's are also increasing. Negative, as my x's increase, my y's get smaller. Okay, and we'll see that. Strength, what we're talking about is how close to the line do my points fall. Okay, we'll get into the idea of the correlation a little more and how we use that to determine our strength. But if I'm just looking at my data now, okay, most of my points are close to the line that I drew in there. And so I'd call it kind of a strong correlation. All right, so when we do get into the idea of correlation, we're going to use our calculators to find it. There's a fancy formula you can use and things like that. But what it does, it measures strength, which are going to be these values I'll talk about in a second, and direction. Okay, positive or negative. And again, very close to the idea of slope again. But people always want a number to determine strength. Okay, so there's no set numbers. I have just given this to people to use kind of as a guideline. Anytime we have a correlation, and correlation we represent with R, that's greater than 0.9, okay, it's going to be a strong relationship. What I probably should talk about is correlations also always going to be between -1 and +1. Okay, so we really should talk about the absolute value of R, just the number part. Okay, when that's bigger than 0.9, it's going to be a strong relationship. When it's somewhere between 0.7 and 0.9, we're going to call it a somewhat strong. And when it's less than 0.7, Okay, it's going to be a weak relationship. And we'll talk about why we cut it off there when we get to R squared. Okay, so there are those rules again for correlation, but number one, remember it's between -1, +1, inclusive. All right. And that does it for section 1.